Okay, so now we're going to do just a slightly different type of problem that combines a couple of things that we already know. We're going to consider the integral from 10 to infinity of 2 over x plus 1, x plus 3. And what we want to do is either evaluate it or show that it diverges. By the way, I should say that that's not always a foregone conclusion that we can do this. There are some integrals where we can show that they do converge to a finite number, even though we can't find the number. That situation actually does exist, but for now, we're simply going to, I will tell you that if this integral converges, we are going to be able to find the number. And let's set out to find the number, and that will hopefully answer the question about whether it converges or not. So observe that what we have here is sort of a partial fractions problem. So what we want to do is we have 2 over x plus 1, x plus 3. So we want to decompose this. I'm going to set that up as a x plus 1 bx plus 3 is equal to 2 over x plus 1, x plus 3. Since this is not our partial fractions unit, I'm not going to bore you with the details. I'm just going to zip through the algebra to find the partial fraction decomposition. Okay, so here we are. We've turned the original problem, integral of 2 over x plus 1, x plus 3, into the integral of 1 over x plus 1 minus 1 over x plus 3. I know some of you are going to say, wait, shouldn't it be 2? No, it shouldn't. You'll have to review partial fraction decomposition if you're confused about that. So we know that this is now equal to the limit as x, sorry, not x, limit as b approaches infinity of the integral from 10 to b of 1 over x plus 1 minus 1 over x plus 3 dx. That's going to equal the limit as b approaches infinity of ln x plus 1 minus ln x plus 3 from 1 to b. Now initially it starts to look like this is infinity because what we have here is we know that the natural log function grows to infinity, so it looks like we're just going to get infinity minus infinity. And I know that some people say, oh, well, infinity minus infinity equals infinity, and others say, no, infinity minus infinity must equal 0 because I'm just subtracting the same thing from the same thing. Actually, both groups are wrong. Infinity minus infinity is an indeterminate form, but fortunately there's a very simple way to resolve that in this case, which is through the law of logarithms. When we take ln of b minus ln of a, we just get ln of b over a, right? So we can do that even with these more complicated expressions, and this is going to be the limit as b approaches infinity of ln x plus 1 over x plus 3, and we're going to let that go from 10, I forgot that should have been 10 there, this is 10 to b. So this is going to equal the limit as b approaches infinity of ln of b plus 1 over b plus 3 minus ln of 10 plus 1 over 10 plus 3. Now, this last term is a constant. In other words, this is just going to be ln of 11 over 13. So the real issue is going to be evaluating this limit, even though technically I needed to put brackets around there because I'm doing the whole limit. Really, it's only the only thing I really care about for evaluating the limit is the expression that actually includes b. So this is going to equal, there's something called the composite limit rule that basically says that the limit of a log is equal to the log of a limit. You would have learned this in limits in Calc 1. So this is going to equal ln of the limit as b approaches infinity of b plus 1 over b plus 3, and then minus ln of 11/13. We already found that part. Now, this is really just a polynomial function. Imagine that I had written here the limit as x approaches infinity of x plus 1 over x plus 3. You would have said, oh, well, that's easy. I just have the highest power. Is the highest power of the polynomial is b, I just take the coefficients of the highest powers, and you'd get a limit of 1, and you'd be right. If you want to do this the old-fashioned way, we can say this is limit of ln b approaches infinity of b plus 1 over b plus 3 times 1 over b over 1 over b, and I've got to keep the ln of 11 over 13 here. That's going to equal ln of the limit as b approaches infinity of, it's going to be 1 plus 1 over b over 1 plus 3 over b, and hopefully you can then see why it is that this expression is approaching 0 and this expression is also approaching 0. So that's going to equal ln of 1 over 1, which is ln of 1. I don't even really need the absolute values, obviously, minus ln of 11 over 13. That's going to equal ln of 1 over 11 over 13, which equals ln of 13 over 11, and that's the answer. Can I even fit this whole thing on one screen? Not really. So there we go. So that's just a review. We went from there to here and got an answer of ln 13 over 11.